Hello, everybody. My name is Florian Edukaushe, and I will be talking about how to create a test matrix and the various steps in creating a test matrix. Let me just pull up my PowerPoint. Okay, so let's go up. Okay, so as we all know, a test matrix contains the input values to be entered and the expected output values to be returned for each test. So for each test that run, we have an input value and an output value. Okay, so let me just go down in order to explain what this test matrix is all about. Let's first look at how to create it. Now, how do we create a test matrix? Now, the first step is by listing the inputs and the outputs of the function in the first column of the table. So let's quickly go up. So these are the inputs. We have character, location, monster. These are the input variables that we will use for this function, okay, called move. So these are the inputs that we will put in here. And for the output, sorry. Okay, I think I made a mistake. This is supposed to be the output. Just a minute. Let me output. Okay. So for the output, I used this formula here in NetBeans for the output. So the character plus location plus monster plus health will give me this output as shown here. Okay. Now, how do we get these variables, these inputs? It can be obtained from the definition of the problem. That's the first step in developing a program or our game. Okay, now the next step is to identify the different uh, data that you would use to test whether the function would work properly or not. So we input in valid data, invalid data, and boundary. Now the valid data comprises of the data that we will put in for it to run as expected, while the invalid data comprises of the data that would um, give throw errors. Okay, now the boundaries has to do with a lower data and a higher data in which sort of an interval in which um, the function or the program would run properly, meaning that if it should go out of this boundary, it will throw an error. So, for example, in our map function, let me quickly go out. We have valid. That means all these numbers, when we enter them, we input them, the program will function properly. But if we should input any of these, the program will not function properly. How do we determine this? Now we have algorithms, okay, and sorry, we have an algorithm, and let me just quickly pull it out. Now you see that in our algorithm, if character is less than 1, you return -1. That means it's not going to function well, okay. But if it is greater than 1, that simply means that truly it is going to function well. So that falls under the valid category. So character is greater than 7, so it will function well. Location, as located in the algorithm, should be greater than 1, and all the other variables. So looking at location is greater than 1, monster is greater than 1. Okay, so the word function well. When we take the second case, 6 is greater than 1, 38 is greater than 1, so it's 13. When we take the invalid part, now, despite the fact that in character it is greater than 1, which is 9, which shouldn't throw an error, location throws an error because it is negative. It is less than 1. So that makes it invalid, as shown in the algorithm here. Okay. Now, monster shouldn't also throw an error. Now, our second invalid test, 10 is greater than 1, 4 is greater than 1. But the reason why it throws an error is that just a minute. Oh, okay. In the boundary, despite the fact that it is greater than, despite the fact that it is greater than 1, it shouldn't be greater than, it shouldn't be greater than 48. Okay, so it should be less than 1 or greater than 48. What I'm doing is wrong. Yeah.